My name is Carlo Bradac, and I'm from Trent University in Ontario, Canada. I'm studying nanomaterials, in particular diamond and hexagonal boron nitride. And the idea is to use this material to do what I call quantum sensing. I use color centers, which they are very sensitive to the external environment. So we can do, for example, measure magnetic field, electric fields, the temperature, and all sort of external stimuli. Lately, I've been interested in determining if it was possible to measure temperature at the nanoscale, map the temperature of the external environment on the fluorescence of these color centers in the material. We have developed a method that I called anti-Stokes excitation of this color center, which gives us a very high sensitivity with which we can measure temperature. But currently, we have only tested it in the lab, but not inside a cell. The most interesting part of this aspect to me is that this anti-Stokes method physically cools the object. So as we're measuring the temperature, very mildly, we are cooling the surrounding environment. This is interesting, of course, in biology, because if you can control the temperature, both by heating or cooling, now we have maybe even a small window, just a few degrees, maybe plus or minus 5, where we can change locally the temperature within the cells. One thing that comes to mind, for example, is immunotherapy. Immunotherapy can be controlled by controlling temperature. And so, for example, we can repress the development of certain cancer cells.